Finally, it's time for our world to witness the revolutionary electric drive, a concept that might sound confusing at first. Words like electric drive and propulsion can seem overwhelming, but don't worry. The Tech Insider is here to break it all down for you. So, without further delay, let's dive into what this groundbreaking invention is all about, starting with the basics of propulsion physics to the future of space travel. So, come along on this journey to understand the future of propulsion. Chapter 1. What is propulsion physics? Before we dive into the electric drive, let's first understand the basics of propulsion physics. Propulsion is the force that moves an object forward. In simple terms, propulsion follows Newton's third law of motion. For every action, there's an equal and opposite reaction. When the rocket engines push gases downwards, action, the rocket itself is pushed upwards, reaction. Most propulsion systems, like rockets or jet engines, rely on this principle by expelling some kind of mass-like fuel to move forward. However, what if we could propel a spacecraft without expelling any mass at all? That's where the revolutionary electric drive comes in, challenging the very foundation of propulsion physics. Chapter 2. The revolutionary electric drive. Dr. Charles Breer, a reputable research scientist, has introduced an innovative electric drive based on a concept called the asymmetric capacitor. This drive is unlike anything we've seen before in space travel. It operates by creating an electrostatic pressure force when a high voltage is applied to a set of capacitive plates. Let's break that down. Capacitive plates are simply two surfaces that store electrical energy when voltage is applied. An asymmetric capacitor means these plates are arranged in a way that is not uniform or even. When a high voltage, sometimes up to 40,000 volts, is applied, an electric field is created between these plates, generating a force. This force is what could potentially propel a spacecraft. What makes this device even more fascinating is its simplicity. The capacitive plates are enclosed in materials like styrofoam, and the design can be adapted to different shapes and sizes. The idea is that this setup could create enough thrust to move a spacecraft, potentially making long-distance space travel much faster and more efficient. Although this concept is revolutionary, it is not without its challenges and controversies. Chapter 3. The challenges and controversies. The main issue is that this technology seems to violate Newton's third law of motion. Remember, propulsion typically requires something to be pushed out like rocket fuel for the spacecraft to move. But in the case of this electric drive, no mass is being expelled. This has led many scientists to question whether this technology can actually work in the vacuum of space. Additionally, testing is difficult, requiring ultra-high voltages and vacuum conditions to eliminate ion wind effects. Ion wind, the movement of air particles due to the electric field, could falsely appear as thrust, so vacuum testing is essential to confirm the drive's true propulsion capabilities. Chapter 4. The possibilities. But apart from these issues, there are three main possibilities regarding how this electric drive might work, each offering a different explanation for the observed thrust. The first possibility is that the observed thrust is due to local interference or misread data. This would mean the device isn't functioning as a propulsion system at all. The second possibility involves interaction with Earth's electromagnetic field, which might generate thrust in a vacuum on Earth, but may not work in space where such fields are different or absent. The third and most exciting possibility is that the drive represents a true propellantless propulsion system. This would defy conventional physics and potentially revolutionize space exploration with continuous acceleration and unprecedented speeds. Chapter 5. The Biefeld-Brown effect. The idea of using electric fields for propulsion isn't entirely new. In the 1920s, a scientist named Thomas Townsend Brown discovered that a charged capacitor, when exposed to high voltage, could produce thrust towards the positive electrode. This phenomenon became known as the Beld-Brown effect. Today, we see this effect in devices called ion lifters, which use a thin wire and a larger foil skirt at opposite polarities to create thrust in the air. The ionized air moves towards the smoother foil, bumping into neutral air molecules and transferring momentum to them. This is how the lifters float in the air. However, the question has always been whether this effect could work in a vacuum, where there is no air to ionize. Brown himself speculated that it could, but his theories were never conclusively proven. Dr. Breer's work seems to echo this old concept, but with a modern twist that could lead to a breakthrough in space propulsion. Chapter 6: The Current State of the Electric Drive. So, where do we stand with this technology today? Dr. Breer and his colleague Andrew have conducted numerous tests in vacuum conditions on Earth, and the results are promising, but not yet conclusive. The scientific community remains skeptical, primarily because of the apparent violation of Newton's third law. More testing and verification are needed, especially by independent labs, to confirm whether this drive can truly work in space. If proven to work, this technology could open the door to a new era of space exploration. Imagine a spacecraft that could accelerate constantly at 1 g, the same acceleration we experience due to gravity on Earth. Such a spacecraft could reach Mars in just a few days, compared to the months it currently takes. This would revolutionize not only space travel, but also our understanding of physics. Chapter 7: The Future Implications. If the electric drive is validated and scaled, its implications could be enormous. For space exploration, it could lead to faster and more efficient missions, possibly enabling human travel to distant planets and beyond. The drive could also be scaled down to smaller applications, much like how the invention of the transistor led to the development of modern electronics. However, there are concerns too. The ability to achieve such high velocities in space could lead to the development of hypervelocity weapons, which could have significant military implications. While the idea of faster space travel is exciting, it's important to consider the broader impacts of such technology. While there are still many questions to be answered, the potential of this drive to revolutionize propulsion is undeniable. Whether it's for exploring new frontiers in space or developing new technologies on Earth, the possibilities are endless. Whatever the future brings, the Tech Insider will be here to bring it to you at the same speed. Thank you for joining us on this journey, and stay tuned for more exciting updates.